Hi, good morning all. Welcome back to our channel. Today we are going to learn about the compensation theorem. Okay, so this is a very important theorem. Let us try to see what is the importance of this theorem. Okay, so in order to understand this theorem well, I had considered this example. Okay, what this theorem is saying is that if in any linear network, linear means it should consist of R, L, C elements. Network means more than one closed path or group of electrical circuits. More than one electrical circuit, I mean two electrical circuit is called as an network consisting of an linear elements. Okay, linear means already I told R, L, C consisting of bilateral elements. Bilateral means which make the current to flow in forward direction as well as in reverse direction. If a network consisting of RLC elements and bilateral elements and impedance of the active source. So let us try to consider this is the impedance of the active source. If the impedance of the branch carrying an current, so the current carried by this branch is how much? I ampere. If the impedance Z of the branch carrying a current I, if it is changes by delta Z. For example, if this impedance is increased by plus J40 ohms to J35 ohms. If the impedance is increased by a value of delta Z, so there is an change of current. So that current is nothing but I dash. Okay, how to find out that I dash is draw the same network, and this is the same network which is nothing but J40, and we have to introduce delta Z. Delta Z is nothing but J40 minus J35. This is nothing but J 5 ohms. Okay, so this we have to introduce, where this we are going to call it as delta Z, and so we need to find out the change in current. So this is called as delta I. This change in current we need to find out. So, and if you have an voltage source, just deactivate that voltage source. Is nothing but making it short circuited, and now this change in current can be observed by connecting an voltage in reverse connection. Okay, so these are the current will flow in this direction, where this voltage source is called VC, and the magnitude of VC is I into delta Z. Okay, so I value is we have to find out the original current, the current what you observed. From here we have to substitute the current and change in delta. The delta value is nothing but how much? Plus J5. This we have to substitute, and then automatically then you can calculate the change of current. The purpose of this theorem is if any impedance is changed in a network, the change in current we need to find out, or the change in voltage we need to find out. That you can find out by inserting an voltage, where this voltage is called compensating voltage, where this voltage is called compensating voltage of magnitude original current. What is the original current of circuit? I multiplied with delta. Okay, so delta Z. Okay, delta Z is nothing but change in impedance. Okay, so this you have to substitute, and then you have to find out delta I. Okay, so when you find out delta I, so this is nothing but current. Current is equal to VC minus 0 divided by J40 plus J4. That's all. You can find out the change in current. That's what the statement of the theorem is. So if you study it, you can't understand. That's why I'm applying on a problem, then you can understand. Now we can see the concept will be clear. In any linear network consisting of RLC network consisting of linear elements RLC and bilateral impedances Z. Okay, so this is impedance Z, and this is nothing but the active source. If the impedance of the branch is carrying a current, what is the current carried by the branch? I. If it is increased by delta Z, what is that is delta Z? Delta Z is nothing but J40 minus J35. This is nothing but how much? J5. It is increased by a value of J5. Then the increment of current, this is called the increment of current, delta I or delta E in each branch of the network, is that the voltage or the current that would be produced by an opposing voltage source, where this voltage is called compensating voltage, is introduced in the altered branch. This is the altered branch of after replacing the original voltage and current source. So replacing the original voltage source means if you have an voltage source, replace this voltage source, I mean deactivate this voltage source and make it like an short circuit. And if you have an current source, replace this current source with an open circuit. This is the concept of replacing with internal impedances. Okay, hope you understood the theorem. Very simple. So the theorem is saying that if the impedance is changing from J40 to J45, the change in impedance will occur. So I want to find out what are the changes in the currents or the voltages. I can find the change in voltage or currents with the help of an injecting a voltage, where this voltage is called compensating voltage of a magnitude of I into delta Z, that has to inject, and if the voltage source is there, short circuit. So before you are calculating this, you have to write down original impedance is Z, and you have to add another impedance of delta Z. So there's nothing but introducing an opposing voltage of V compensation in the altered branch. So that's how we can calculate. So since we are compensating the voltage, that's why this theorem is called compensation theorem. So the total change in current and change in voltage I can find out by introducing a voltage where this is called compensating voltage. Then we can find out the change in current and change in, so then we can find out the change in voltage or change in current by using a theorem by introducing a compensating voltage. That's why this theorem is called compensation theorem. Hope you are able to understand. So if I am running a little bit fast, nothing to worry. Just study the statement again. You can understand better. Okay. So in any linear bilateral impedance consisting of impedance and active element, if the impedance of the branch carrying a current of I amperes is increased by delta Z, then the increment of current and the voltage in each branch of the network, that is voltage and current, would be produced by an opposing voltage of compensating voltage introduced in the branch after changing replacing those voltage source and current source with their short circuit and open circuit. Hope if you're able to understand, just give an like to my explanation and share with your friends those who are studying the same subject. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulasiram. Thank you for watching the channel. We'll meet in the another video. Yours Ram.